Okay, so our purpose today is to talk about the basic notation of Venn diagrams and then to get through as many different applications of Venn diagrams as we can. They are located, kind of mixed in various places in the chapter, but I can go through and pick some of them out for you. But first, let's start with the basic notation. I am not interested in doing every single problem in the packet. There's just too many of them. But let's get the general notation figured out, okay? So number one says we're going to do a little shading here. And the notation is A intersect B. That upside down U, you probably remember from geometry, is the symbol for intersection. Everybody remember that? And the mathematician would call that an and. The word associated with the intersection is and. So you are to shade in everything that is an A and B. That's pretty easy. That would be the football. So that's what you're going to shade right there. Everything that's an A and B. Now, next to that, I'm going to go this way. Next to that, it says the same thing, only there's a bar over the top. Anybody know what that bar means? It means everything except what's in A and B. So you look at this part under the bar and you think about what that is. That is this section right here. And then you look at the bar and it says, okay, everything except that. So what we're going to shade in is everything except what's in A and B. Now you're going to do a better job shading on your thing. It makes my boards too dirty, so I don't shade very much. But everything should be shaded except this. The bar over the top is the symbol for not. Okay, so everything not in there. All right, so make sure everybody, you get your name on that piece of paper. That's my attendance record, so make sure you've done that. Okay, so now we have this. Now, does everybody recognize now it's a right side up U? A right side up U from geometry. Anybody remember the word for that? This is the word for, or this is the symbol for intersection. What's the symbol for, or what's the word for the right side up U? Union. That's the union symbol. And the intersect symbol is associated with what word? I already told you. And. The union symbol is associated with or. So this is everything that's an A or B or both. It's everything that's an A or B. So you're going to color in the entire thing. Everything that's an A or B or both. So if I know we're using A's and B's because that's what they do when we study sets, but think of it like this. A is all the people that like M&Ms. And B is all the people that like Snickers. So what have we got here colored in? We got everybody that likes either M&Ms or Snickers or both. That's what we've colored in. Now, what's going to happen in the next question? Again, I'm going to cross the page. What's going to happen when we put the bar over the top of that? You'll be shading everything except the circles. Because again, when you read this, think about what that is, and then when there's a bar over it, color everything else. So this would be everything out here would be colored in, nothing in the circle. You get the hang of that? What do you think? Okay, so now I'm down at the bottom right. What do you think this means? Okay, well, what does that mean?
Everything but A.
Yeah, that's right. That means color in the A circle. Putting a bar over it means color in everything except the A circle. So we're coloring everything except the A circle. Now, be careful. Is there part of B that also isn't colored? Yes, there has to be, because there's that overlap. And this says, if you're in A, you don't get counted. That's probably not a very good way to say that in terms of the assembly we just saw, but if don't color in, if A is everybody who likes M&Ms, then you are coloring in everybody who doesn't like M&Ms. Even if they like Snickers too, it doesn't matter. If they like M&Ms, they can't be colored. All right, we'll do one more on this page, which is a good thing because there's only one more left, I guess. So what does this say? Oh, by the way, some books use this notation. So don't be confused. They mean exactly the same thing. This means not be. Okay, both of them mean the same thing. All right, so here's your deal. Now, what are we going to color in? We're going to color everything in A. So start with that, everything in A. Or, meaning we can include everything in A, we can also include what? Everything that's not in B. Now, sometimes kids get confused, so let me color in the answer. The answer is going to be everything in A. We've already done that. Now I'm going to color in everything that's not in B, and that's the answer. Now, sometimes kids get confused because when we say not in B, you're thinking, well, wait a minute, Miss Ford, that's in B. This section right here is in B. But what's the word I use here? I don't say and. It's not and. It's one or the other. So you don't have to fit both of these. You have to fit one or the other. So does this fit the first part? Yep, so it gets counted. And then you shade in everything that fits the second part, and then it's all that. Okay? Everything and all of that. All right. Now on the back we got 3 circles, so you just pick one. Which one do you want to do? We only have time really to do one of these, so just pick one. Which one do you want? The first one? All right, we can do the first one. Three circles. And we are doing, oh, you picked an easy one. What does this say?
You should pick the last one. So.
All right, that's right. We'll do the last one too, because this is an easy one. What does this one say? You gotta be in A, and you gotta be in B, and you gotta be in C. So where are you? If you have to be in A, in B, in C, because this is and, where are you? Right there. Those guys right there. That would be like me saying to you, A is the people who like hot dogs, B is the people who like hamburgers, C is the people who like pizza. What are these? These are the people that like all 3. That's what that means. Okay? So now we'll go down, we'll do the last one. The last one on the page. And it says, okay, now, as with all mathematics, we start in the parentheses, right? That's just what we do. We start in the parentheses. So forget that for a minute. Look at right here, just this part right here. What does that say? That's an or. So that means we want to color everything that's in circle B or circle C or both. That's everything. So everything in B or C or both. Would you agree that I have colored in B or C? Okay. Now, what does this say? Everything in A. So everything in A would be this. Would you agree with that? Now I'm going to do my answer. Because my answer says, because that's a and, my answer says you got to be blue and red both. The answer is the part that's blue and the part that's red. So what is the answer to the question? You have to be blue and red. Aren't you this right here? Did I get that right? Is that the part that's blue and red? This isn't too bad. It's pretty easy. So let's look at the next page. The next page gives us some information, and then we're going to answer some questions based on that information. Okay? So everybody on page 2? Now instead of A's and B's, we've got like stuff going on. We got, apparently there's people who like rock music, people who like rap music, I don't understand that, and people who like country. Okay. How many people are represented in the diagram? Math is a participation sport. I need you to participate. Figure it out. How many people? How many? 49. How'd you get 49?
I got 59.
How'd you get 59?
18 plus 17 plus 24.
Okay, now be careful. 18, what are those 18? Let's talk about that. Look in the Venn diagram where that is, that 18 is. What are those people? Who are those people? They are the only rock and roll people. Right? So there's 18 people that like only rock and roll. But what about those 11 that are next to the 18? Don't they get counted? Who are they? They like rock and rap. Shouldn't we be counting them also? Okay, so with that in mind, how many people are in the diagram? 86? So there's 86 people in the diagram. Does everybody understand that we got to count all the different people? All those different sets of people we have to count. So there's a total of 86. All right, next question. How many people like country? The answer is not 17. What's the answer? 33. Country is the bottom circle. How many people are in the bottom circle? You added it up. What did you say? 33. If one person is chosen at random, what is the probability that that person will like rap music? And if there's, in introducing you to the notation, probability of rap, what would that be? 38 over 86. Let's think about that for a minute. I'm not sure that's quite right. Over the 86, I get that. That is exactly right. Where'd 38 come from? Okay. So what should it be? 43. You want to total up which is 1/2, isn't it? You want to total up everything in the rap circle. So that includes people that also like country, people that, don't like rock, whatever. It's everybody in the rap circle gets counted, and apparently there's 43 of those. Would you agree with me? And there's a total of 86 people. So the probability is 1/2. Do you understand the basics of probability? That's kind of what this section, this little unit you're beginning is about. Probability is what we call the number of successes, that is what you want, over the number of total options. So there are 86 total people, and there are 43 of them that do what we want, like rap. All right, number 4. If one person is chosen at random, what are the odds for picking a person who likes country. Okay, tell me your thought on that. And this time we're doing country. What'd you say?
33 over 86.
All right, I didn't add them up. I know where the 86 came from. I didn't add up. Is 33 the right number? Those are the people in the C circle. Now, I'm going to shoot you down. You made the same mistake that every average person on the street would make. If you walked up to the average person on the street and said, what are the odds? That person's going to say 33 to 86. But these aren't the odds. This is the probability. This is the probability that someone likes country. Okay? That's your probability. Odds are different to the mathematician. Odds are the number of successes over the number of failures. In other words, odds are the number of people who like country divided by the number of people who don't like country. So what would the odds be? Not 33 over 86. It would be 33 over 53. And a lot of times, odds are written this way. You've seen it if you've ever been associated with any kind of betting, like at the racetrack, or even like during the NCAA tournament, if they have, odds posted. Odds are often written sideways instead of up and down. So, fundamental difference. Probability is what you want over the total. Odds are what you want over what you don't want. Okay? So let's flip a coin. Talk about one more vocabulary word. Let's flip a coin. What's the probability of getting heads? 1/2. Right? Don't make it hard. That's easy. What are the odds of getting heads? 1 to 1. Those are called even odds. So when somebody says to you, oh, that event, whatever it is, has even odds, what does that mean? There's the same chance of it happening as there is of it not happening. Even odds. Okay. 50% probability. Even odds. All right. If one person is chosen at random, what are the odds against picking a person who likes all 3 types of music?
7 to 79.
What does the class think? Actually, it's the other way around. It's 79 to 7. Because what are these people? These are the people who don't like all 3 kinds of music. And that's what we want in this problem. We want them not to like all 3 kinds of music. So it's 79 to 7. So there are 79 ways to pick somebody who doesn't like all 3, and there are only 7 ways to pick somebody who does. All right, is that settling in? Yes.
So if you take out the word against, could be right.
Yeah, it would be
otherwise.
4. It would be 4. The odds for that happening would be 7 to 79. The odds against it happening are 79 to 7. All right, now turn it over, because this is where things get fun. You have exactly the same scenario now, except they didn't fill it in for you. You have to fill in your own Venn diagram, which is how it works normally. You got to figure it out. So here we go. Here we go. We've got math, science, and social studies. And then they tell you about all these things. Now, they say 100 people were asked if they liked these subjects, and everyone answered that they like at least one. That is an important thing to know, because normally we put a Venn diagram in a box, right? And when we do that, we're doing it because usually what happens is there are people who don't fit any category. But they're telling me there are 100 people in this box, and everybody likes something, at least one. So we're not gonna have any leftovers out here. All right, so here we go. What do you think? Where do you want to start putting numbers? Anybody thinking about putting a 56 right here?
No,
No, good, why not?
because it'd be more than 100 if you put them all in there.
Well, yeah, because when you put a 56 right there, in that spot, in the Venn diagram, that would represent which people? The cool kids who love math only. That's who these are right here. But that's not what the 56 is. 56 is everybody in the whole math circle, right? There aren't 56 kids who just love math. There's 56 kids who like math and maybe other things too. So now I'm gonna put the 56 there. Ooh, good grief. What am I gonna, is there any number I can put in this picture? The 6. The 6, that's right here, right? Those are the guys that like everything. Right, now there's 18 that like math and science. 18 kids like math and science. Now be careful. Math and science is right here. Would you agree that that football is the kids who like math and science? So what am I gonna put right here? 12. Because there are 18 in the football, but you already marked 6 of them down. So that's a 12. Now, 10 like science and social studies. So this football right here is 10. Would everyone agree? So this must be 4. 12 are in this football, math and social studies. So this has to be 6. Now you can tell me what number to put here. Because we know the entire circle, math circle, contains 56 kids. How many of them have we already counted? In the math circle, how many kids have already been counted? 24, which means there must be, what, 32 right here? I know the science circle contains 43, but I've already counted 22 of them. So is that 21? Check my arithmetic. 35 are in the social studies circle, but I've already counted 16, so 19 there. Now, if this happens to be a test or quiz, you could check yourself real easily. What should happen when you add up all these numbers?
You get 100.
You better get 100. If you don't, then something's wrong because they told you there's 100 in there. All right, so now we can answer the questions. How many people like math only? 32. That's these guys right here, right? How many people like science only?
21.
And how many people like social studies only? 19. Everybody okay with that? Okay, now what I would like for you to do is, if you have a book, get your book out, and I'm going to show you an application of Venn diagrams. And if you don't have a book, then you're going to have to take a picture of this page because, again, math is a participation sport. So, we're on page 729 if you have a book. If not, come take a picture of it. 729. And we're going to use Venn diagrams to do a probability question. Yes, sometimes my students do something called airdrop. I do not understand that, but if that works for you, I may even use the wrong word. I'm not sure. Maybe that's not even the right word. Okay. There's one more problem in here. I don't know where it is. But anyhow, all right, here we go. Number 27. A and B are events in a sample space S. All right, so basically what that means is, here you've got your A and here you've got your B. Now, the P stands for probability. So they're telling you the probability of A, this is question 27, is 0.6. The probability of B is 0.5. And the probability of A, now I'm going to use the official notation. Instead of writing the word and, I'm going to use what symbol? Upside down U, A and B, and that probability was 0.3. Now draw a Venn diagram that illustrates that information. Where do you start? It's just like this one. Where do you start? The middle. So the overlap of A and B, the football here, the overlap of A and B would be 0.3. Does that make sense to everybody? Now, what goes here? 0.3. Because we know that the probability of the entire A circle is 0.6. But since you already marked this part 0.3, that only leaves 0.3 for this. And what about out here? 0.2. Now, this is a is that okay with everybody, 0.2? All right, this is a probability problem. What do you know about the total probability of any event? It has to add up to 100% or 1, right? That makes sense to everybody? So look at the probabilities represented here. What do these add up to? 0.8. What does that mean? There's 0.2 out here. So if the probability that your family owns a Chevy is 0.6, and the probability that your family also owns a Ford is 0.5, there's a 0.2 probability that what? You don't own either one. You drive some other kind of car. Those people don't belong in either circle. All right, now we're going to answer the questions. Draw a Venn diagram. We did it. Find the probability that A occurs, but B does not. Well, you took a picture so you know what the answer is. But can you tell? What's the probability you have A and not B? That would be right here, wouldn't it? And if I were using official notation, not the words, it would be the probability that A occurs, but not B. Either with that or with the bar over the top. That's A and not B. What's the probability that B but not A? 0.2. What's the probability that neither A nor B? That's these guys out here. That's 0.2. All right? Now, I've got one more question I want you to think about for a second. Let's suppose we have a class of 30. All right, this is the problem I can't find. I forget where it's at. But let's suppose we have a class of 30. Okay? And I know that every single person in the class likes some kind of candy. Okay? Likes candy of the kinds I have. So I say, okay, kids, raise your hand if you like M&Ms. And 20 hands go up, they like M&Ms. Okay? And I say, all right, raise your hand if you like Hershey Kisses. And 23 hands go up. Now, everybody in the room has raised his hand. Everybody in here likes either M&Ms or Kisses. The question is this. What's the probability that a random student in the class likes both? Now, can you figure that out? first glance, we have a huge problem. How many kids are in the room?
30,
How many hands went up?
42.
We got a problem. Too many hands went up. So what does that mean? What had to have happened?
Some kids like that.
Some kids like both. Since everybody raised his hand, we don't have any people who don't like candy. Everybody raised his hand. What do we know? Where's the overlap? How many kids were in the middle? 13. Absolutely. So the answer to the question is 13/30ths. Now what if the question had been how many like only candy kisses? Or not how many, but what's the probability of only candy kisses? Well, you had 23 altogether, right? 13 of them are here, so 10 of them are here. So the answer would be 10/30ths or 1/3. One more question and then you get to escape. What are the odds that somebody likes only candy kisses?
1 to 3.
What's 1 to 3?
Or 3 to, yeah.
1 to 3 is your probability.
3 to 1.
3 to 1. Alright.
What are the odds that you like only candy kisses? How many kids like
10 to
only
20.
candy kisses? How many like only candy kisses? 10. How many don't like only candy kisses then? 20. Your odds are 1 to 2. If your probability is 1/3, kids, what does that mean? That means 1 of what you want and 3 total. Well, if there's 1 of what you want and 3 total, then how many must be that you don't want? 2. Yeah, sure. 1 to 2. So your odds would be 1 to 2. All right, you're out of here. I don't know what your homework is, but I'm sure it has something to do with something. Check Schoology. She probably posted it for you.